Let's discuss the common data questions. Basically, it involves the 48th and 49th question. Both have the same common data. And this is from test 2, and the topic is thermodynamics. Okay, so let's see the common data. A certain quantity of air is there inside a closed system where the initial conditions are given. The initial volume is 0.25 meter cube, the pressure is 15 kPa, and the temperature is 25 degrees centigrade. Whereas the volume, okay, now they are basically compressing it by this law. So this is the compression law, and the final, such that the final volume is this much. So let's put this in a PV diagram where it starts from here, it ends here, the volume decreases and the pressure increases. Okay, so what is asked is the final temperature T2 is asked. We don't know P2 also. Okay, so let's solve the problem number 48. So this is the common data. Okay, so this law they have represented. Let's put this 1.3 for time being as n. So PV is equal to C. Assuming that the gas is ideal, so the air is ideal basically. So one can use PV is equal to MRT, assuming that it's ideal. So we need to find out T2. So we know V1, V2. So let's get an expression in terms of temperature and volume. So let's substitute P, which will be T by V, and the rest of the things MR is constant. Okay, so and basically we are substituting it for P, so it is T by V. So Tv n minus 1 is equal to constant, or T1 V1 n minus 1 is equal to T2 V2 n minus 1 is constant. Okay, so let's substitute the values. Remember that T1 temperatures you have to substitute it in Kelvin, and the volume is, if n is 1.3, so it becomes 0.3 at the power. T2 is required, volume V2 is 0.125. So I need to use the calculator for this, and if you use that you will be getting 366, and so the answer is close to B. Okay, so now let's discuss the 49th, which is a common data. So the work done by the system, remember the work done by the system in this polytropic process, which is governed by P equal to n, is given by P1 minus P1 V1 minus P2 V2 by n minus 1. But for that I need to find out P2. So let's use this equation at state 1 and state 2 to get P2. So because then only I can use this and get the work done. That is what is asked. So P2 is basically P1 V1 n by P2 power n. P1 is 15, volume is 0.25, 0.3 by P2 is 0.15, 0.3. Sorry, this is 0.125. Volume is reduced by half. So this thing gives me the close to 36.934 kPa of pressure. So let me substitute in this. So P1 V1, so I'll get 36.934 into V1, which is 0.25, minus this is P2 actually. Okay, so this is P2. So ultimately I'm just substituting it. This is first. So P2 I have substituted. V2 is 0.125, and plus this, basically I'm just writing this second term as first and the first term as second. So P1 is 15 and V1 is 0.25 by, so this is the second term, remember, and this is the first term. Okay, don't get confused. Okay, so this is close to 0.2917 kilojoules. So remember, this minus comes because the work done by the system is negative. In fact, the work is done on the system, and that's why the volume decreases and the pressure. So we need to do the work in order to compress it. That's why this minus sign signifies that. Okay, so the answer is B. Thank you.